Hey everyone. So yeah, I know the session starts at 6 p.m. So just wanted to know how many of you guys are like, is it like the first blockchain related workshop?
Yes,
Okay, awesome. Has anyone had any prior understanding of blockchain as well? Okay, maybe a few. Yeah, no worries. I think we have the right speakers for that, and we'll also ensure that this is like a very interactive sessions. And yeah, make use of the raising hand feature whenever you want to ask something, or you can post the questions in the chat as well. And I think the team from BMS will also ask the questions at an appropriate time. Yeah.
Yes, sir. Hello, sir. Has everyone from your team joined in?
Yeah, just a minute. Aishwarya is joining. Then once he joins, we can start. Just a minute.
Okay, sir.
Yeah, he's joining now. Yes, BMS team, we can start. Start with the intro.
Okay, sir. Thank you. Good afternoon to one and all present here. I'm Ranjani Ravyayur. On behalf of BMSCE IEEE Student Branch, I would like to extend a very warm welcome to Dr. Prakash Kamaraj, Aishwari Gupta, Shrikant Alva, and Sachin Matta from the Indian Ocean Program and Ocean Academy. I would also like to extend a very warm welcome to all my fellow students present here today. In today's world, artificial intelligence, data science, and blockchain technology are hot, in-demand topics in the industry and already have a widespread application, but they still hold an exponential scope for growth and innovation. Today, we have with us Dr. Prakash Kamaraj, an AI and blockchain advisor and Polygon advocate, Aishwari Gupta, a DeFi operations lead at Polygon, and the founder of Battle Brains and Blockchain Byte. We also have with us today Shrikant Alva, an experienced software developer and blockchain mentor, and an Ethereum, NFTs, and smart contracts expert. We also have with us today Sachin Matta, a blockchain developer and Cosmos India decentralized finance expert on Ethereum. I would like to extend a very warm welcome to you all, and I now request Dr. Prakash Kamaraj to take over.
Yes. Hi everyone. Can you see? I think my video has some issues, but yeah, I think thanks for the introduction, and I think we're glad to have such a very good active participation today along with the guest speakers. So I'll just take 2 minutes here because we can always moderate in between and take some questions. So these are three different things, right? AI, ML, and blockchain. But to put in context of what's possible in this space, it's kind of very essential to understand the blockchain basics first. Of course, some of you would have heard and read across, but these fundamentals is always the first key to understand everything that comes after. Because without the blockchain, it's difficult to understand how you can actually perform data science as well on the same. So in context of that, we have some speakers today who make sure that we deconstruct the basics for you, and then we can actually get on towards the data science part, which will be covered in the essentially the last 50% of this workshop sessions. So yeah, today, without much ado, I think I'll welcome Aishwari here. It's a very good friend, mutual friend of mine, and as well as he agreed to come in short notice, and he's very much active in the Polygon community. I'm sure most of you would be heard of Polygon by now. And we also have folks from Cosmos India, which is like at Persistence, it's the Indian wing of Cosmos ecosystem. That's also one of the leading blockchain solutions. So yeah, Aishwari, you can go forward and greet the students. Mute.
Yep. Thanks, Prakash. Hello, everyone, and let's start with something which a lot of people and everyone here has been hearing the word about blockchain, and it sometimes is like overwhelming to understand what the technology is all about, and sometimes it's also like what exactly. So let's say if someone comes in and tells you in just one line what is blockchain, and we say that it's just a way in which you can store data. Now, when you think about it, you think, okay, it's a way to store data. Then how exactly blockchain is going ahead and disrupting so many technologies or so many systems that are currently out there? And why exactly like all the VCs and everyone is coming out and investing in just a storage mechanism? I mean, don't the current storage mechanism work? Or is there any problem with the current storage mechanism? Or what exactly did blockchain solve for me that it has so much value today and it has so much interpretations and so many things, use cases coming here and there, just left and right? So what exactly is that one thing that blockchain is enabling for us? So I'll just present a small presentation for you here. So whenever you're talking about blockchain, one thing that you have to understand is why exactly or what exactly blockchain came into picture for, and how exactly is it solving something. So I'll just do it in a very simplified format. And let's say we were talking about internet today. So internet has been here with us for like almost 4 decades, gave us a lot of information about emails, .com, World Wide Web, but everything that was moving on internet was just about information. So internet has been a very well thing or a very good thing when we talk about reducing our cost of search. Today we have to just go and Google something. It is also helping us get a lot of collaborations online. Today we are sitting at our homes and collaborating across the globe. We also don't know folks from anywhere around the world, but we're still collaborating. Why? Thanks to internet. And it has been very helpful in that, and all in exchanging information as well. But even with all that information flow, there is something that is missing. If you talk about establishing an identity. So today, let's say when I'm giving this webinar, I do not even know who exactly behind a screen is sitting and listening to me, because all I can see is just a name maybe. So when I'm just seeing a name, how is it possible for me to actually go out and actually establish that identity with someone whom I've met online? Then second thing is, how do I trust someone while if I do not even, how do I transact with someone if I do not even trust that person? So in 1992, there was this person who was also known as the father of smart contracts, Nick Sapzo. So Nick Sapzo at that point of time said one thing, or he wrote a white paper in which he said that there is something called a God protocol. Now, what amazingly he said, and that at that point of time made a lot of sense, was when internet was coming, these third parties in between were the God. Why? Because let's say I met someone over the internet, and let's say I want to go ahead with a business collaboration with that person. If I do not have this third party with me, I would never be able to go out and do any business with him. So these third parties turned out to be gods who were enabling the way internet worked. But as people evolved, as technology evolved, these gods no more remained gods. What happened? They started getting hacked, all our data getting leaked, and there is no way in which I could go out and preserve that data. So that is something which came into picture. So today, if we want to trust someone, we before blockchain, we were still waiting or establishing, or just imagine a bank transaction. When you're doing a bank transaction, you're trusting your payment provider, you're trusting your bank, you're trusting so many people in between, so that your transaction is actually going out and is becoming actually successful. So that brings a lot of thoughts in your mind. Can we go ahead and can we remove these third parties who are there in between and still maintain that kind of trust? So in a way, in Nick Sapzo's word, removing the God in this word is what blockchain brought us, or blockchain came into this picture for. And that is why blockchain has become so much important. So 3 problems that I have mentioned here is, first of all, identity. Cannot establish the identity over the internet just by looking at someone or meeting someone online. Second, cannot without validation cannot move money. You need banks and intermediaries in between to go out and do that for the transactions. Otherwise, we'll be held up in double spend and scams. And then when we talk about such people, so like yesterday only I was talking to someone in the tribal areas, and that the person said that in order for someone to go out and actually deposit 100 rupee in a bank, the bank is 20 kilometers from that from that village. So you have to actually travel, go to that bank, come back. So traveling through a bus maybe would cost you somewhere around 20-30 rupees. So it's not viable. So that is why what is happening is a lot of people are not even able to go out and connect to the financial systems. And when they cannot connect to the financial systems, this is where what internet promised us, a economy where everyone could be connected and everyone would be equal, did not come out to be in the picture. What came out was huge giants consuming our data and making money out of that. So these were the problems where blockchain came into the picture and in a way was able to solve this problem. So what exactly is a blockchain and how exactly blockchain works? So yeah, the best way is go out on the internet, find a definition, and okay, wow, this is blockchain. But let me explain it to you in a fashion which is more easy and understandable. So let's take this example where when you're talking about what is blockchain, let's take 2 examples. One example is, or I'll give you another example because most of you guys have been into colleges and universities or schools. So let's take that example. Imagine you were in class 12th and you guys wanted to go. You have a bunch of friends who wanted to go for a movie. Now, when you guys wanted to go for a movie, one thing that you wanted to do was, so it's not that, let's say 5 friends are going out, everyone will buy their own ticket. Maybe some person will go and buy the tickets, someone might go and give the transportation costs, someone might go out and give the food cost that is there, and at the end you all touch that expenses and make that payment. Okay, that is how it is done, and I think that is how everyone would have done it. Nobody would have individually done all the expenses at the hall. Now, the problem is that, okay, we are a bunch of friends, it's okay, everything is fine. But sometimes what happens is, like, let's say a new person comes in and he books the tickets, and what happens is you have in your mind, hey, there would be a very good discount that he would have got from that particular bank account or from that particular debit card, but he is not disclosing that to us. So he is basically taking money more than he has actually spent from all of us. How can we solve it? First of all, we would not go out and say anything to them because we would not want to disrupt our relationships. So what would we do? We would basically go out and we would basically not do anything, but it will always be in their mind. One way what you could do out is like having a splitwise or something. And in the splitwise, what you can do is you can basically say that, okay, if you have made an expense, just upload the bill, upload the screenshot, and everyone can see that. Or do it in a Google sheet where you add all the email IDs, then everyone can see all the bills in there, and everyone is none the wiser. Now, just elaborating on this example, the problem is this was just a movie where everything was on a Google sheet. Now, this Google sheet, the data is something which is where your data is something, first of all, is not immutable. Anyone can go out and anyone can make changes in the data. If others are not looking, you could actually go out and do that. The second thing is, once that data can be changed, the second thing is also that, let's say it's a movie data, it's a very small data buyer, which is with Google, and it is not very private or something, so nobody cares. But imagine this with the startups who are actually banking upon the whole Google Drives and the Google ecosystem to go and do their business. The data is something which is stored on Google Clouds or databases. Now, when we talk about these databases in Google Clouds, they are mostly centralized in nature. Centralized in nature, basically they have their backups being created every 1 minute or something, but they have a centralized data point or a data center where all this data is getting stored. Now, when all this data is getting stored at one single place, there are two problems which is coming. One is from the inside and one is from the outside. The one from the inside is because they will all go out and say your data is particularly 100% safe. Nobody can go out and check it. Nobody can steal your private information. Yeah. But if they want to do it, they very well have the capacity to do it. So that is the first thing. The second thing is, whenever you are having a single data point or a single place where all the data is getting stored, there is a chance that a lot of people or hackers can go out and attack that one single data point and make it vulnerable. And when it becomes vulnerable, your data also becomes vulnerable, and that is why we see a lot of hacks and exploits happening, because they're all in centralized databases. Now, this is another problem which is there. So anyone can edit that data within the organization. Anyone from Google can go out and modify that data. Anyone from outside, if they are able to hack it, they can change the data. So there is no way in which you can say that the data is secure. Yeah, there are a lot of firewalls and everything that they have built. But if they were so effective, why there is a daily hack happening across the globe? So that is one thing which is happening. So the first thing, that you are not able to go out and store that data in a way which we wanted it to be. Now, what happens with blockchain is, whenever a data is stored in a block and is put in a blockchain, what happens is the data becomes immutable and timestamped. Immutable means that you cannot go out and now edit it. I will talk about Bitcoin, let's say Bitcoin blockchain. So when you have written anything on that block and that block has gone into the whole chain, yeah, there are some reorganizations and everything that happens. But if I say from a 5,000 feet view, your data becomes immutable, which means now you cannot go out and you cannot edit that data, you cannot modify that data, you cannot delete that data. All you can do is add more data to it. Which, first of all, and all the data, once it has been added into the chain, what happens is it becomes timestamped. Now, another thing what happens is, here in the first example that I was talking about in Google, the data was being stored at one single place. So from the outside, if hackers wanted to go out and take a dig at it, they can most certainly do it because it's just one data source. When I talk about Bitcoin, let's say there are somewhere around 15,000 active full nodes which are working right now, which means this is the minimum. I'm not saying that this is the maximum. So this is the minimum places where the same data is getting stored. So let's say someone or a hacker gets hold of that data and wants to modify this data now. So in the centralized one, he just has to go and attack one particular place. Here, when you have to actually go out and attack a network on the Bitcoin network, what happens is you will have to go out and attack at least 51% or more of the nodes to make or to change anything that has been written on this particular blockchain, which means you need a huge amount of computing power. And because these nodes are spread across the world, you have to actually trace them and find out how you can actually go out and challenge that data. On Google, what can happen is, let's say this happened with AWS, where what they did was, if you were deploying your applications on AWS, they went out and launched a version of their Java. And they said that if you're not using this particular application of Java and you're not upgrading from the existing Java codes that you're using, what will happen is after 2 years or after 1 year, you will not be able to go out and you will not be able to store your data in the AWS servers. So here what happens is the decision making is something which is very centralized. If AWS wants it, they will go out and they will do it. Well, when we talk about let's say Bitcoin, if any upgrade has to happen on the chain, you need a majority here. Even the last Taproot upgrade that happened, the total majority reached for more than 90%. 90% or more of the people agreed that the Taproot upgrade has to happen. So that is the amount of that. So here what happens is not one single entity can go out and take the decisions. Imagine this case, if you're not understanding this here in Google, imagine this with Ola and Uber drivers. When what happens is often you see that they're striking and everything. And the reason when you go out and ask them what exactly is the reason, they will say that the terms and conditions have been changed by the company and now it is now it is less beneficial to drive a car with them. So that is what happens with a centralized server, with a centralized management, and which a decentralized or blockchain network is trying to solve. So a blockchain in the most simplest terms is a timestamp series of immutable records of data, which is managed by a cluster of computers and is not owned by a single entity. Once your data has been completed and entered in a block, the blocks get created, and after creating a block, it finally gets mined, and then that block actually goes out and is put into the existing chain in a chronological order. So this means that there's a proper audit trail that has been created here, and through this you actually know when the data has been created. And addition of more and more blocks to the existing chain means that what is happening is you're going out and you are just enabling one more layer of security with every block that is adding to it, because once more and more blocks get added to it, it becomes very, very difficult to actually go back and edit that data or modify that data. So that, in the most simplest terms, I'll say, is what a blockchain is all about. So the blockchain network has no central authority and is shared and immutable, like I told you. The information on it is open for anyone, everyone to see. Now, when I go out and tell this that is open for anyone and everyone to see, what does that mean? Does that mean that I can actually see who has done the transactions? Again, I'll take the example of Bitcoin again here. The answer is no. You do not go out and you do not have the 100% visibility of the data. What you have is a pseudo-anonymous identity which is created, which means that you can find out who has done those transactions if you know one particular thing about that whole transaction. Could be the address of the person who has done it. So if I know, let's say, Sachin's address, and I know that this is where Sachin keeps his money, so I can exactly see from where or how or to whom, to which address, Sachin is sending the money. So that way it becomes pseudo-anonymous and not completely anonymous. That is where the information is open. So if you go to Blockchain Explorer, you can see all the transactions, but you will not know who exactly did that transaction until and unless you either know the transaction hash or you know something, a certain trait about that particular transaction that has been done. And hence, anything built on a blockchain is by its very nature, it becomes transparent, and everyone involved in this is accountable for his action. Imagine, you would have seen a lot of papers going out, like the FinCEN leak happened, the Pandora box opened, the Panama papers were there. There were so many papers and so many documentations that were leaked. Until date, there has been no action, or there has been no arrest, or there has been nothing. The reason is nobody is able to go out and nobody is able to actually go and establish that accountability, that exactly to know who exactly has done this transaction. When you do these transactions through a blockchain, you become exactly liable for it, and you become exactly like involved and accountable, because one can see from which address this whole transaction. Even for the voting, you exactly know who has originated or who has said yes for a voting or who has said no for a voting. So that way, what happens is this blockchain, which is just on a very simple level, a way in which you just go out and you just store the data. A lot of things have changed here in this particular context. Now, another thing, apart from just doing that peer-to-peer transaction, without any intermediaries in between, another thing that blockchain and a lot of development happened over blockchain on this was smart contracts. Now, what happens in a smart contract is basically, let me again make it very simple for you. Imagine smart contract is a vending machine. Now, when you talk about a vending machine, what exactly does a vending machine do? A vending machine, basically, let's say I want to go out and buy a can of Coke, at an airport on a vending machine. So what I'll do is something. Let's say I'll click on the item number, which is representing Coke. At the back end, there is an if-else statement that gets created. Now, this if-else statement will, let's say, the moment I click on Coke, it will go out and check if they have Coke or they don't have Coke. If they have Coke, it will go further. Otherwise, it will say, sorry, we do not have Coke. Is there something else we can serve you with? Now, if the answer is yes, the next thing that it will ask is, what is the quantity that you want to purchase? Again, what will happen? Let's say you enter 3, and the total quantity inside is 5. So what will happen is it will go ahead again, and going ahead again, it will just go out and check, okay, is the number of quantity that is asked available or not? If it is available, what will happen is, again, it will proceed, and then it will say, yeah, this is the amount that you have to pay. The moment I insert the payment inside, it will check whether the amount is equal or it is exceeding the amount for which the Coke are worth. Then it will dispense the Coke, and if any remaining cash is there, along with it. So that is where what happens is, this is exactly what a smart contract is all about. An if-else statement, which you have to build conditions on, and based on those conditions, what happens is 2 or more people can go out and be in it. Now, benefit of a smart contract versus an average contract is, when you talk about a smart contract, in a smart contract, the best thing is it's written on codes, versus any contract which you do on a paper is subject to speculations. Which means, let's say there's this line which says that on the 1st of every month, Sachin has to pay Aishwarya $10,000, and the contract is started from 22nd of that month. Now, this is open for speculation. I can say, the moment it came into picture, I'll say, Sachin, because you did not say from which month, so I'll assume that from this month my $10,000 are payable. So give me my $10,000, even if today is 22nd. Sachin, on the other hand, it says that it's from it's on the 1st of every month. So when the 1st will come, I will pay. So this became a discrepancy here. However, when you put it in a smart contract, you will have to actually build out and say that, okay, this is the exact start date from which this payment has to go ahead. So that ambiguity which is there in between is removed, because all the contract terms are written as a code, and as a code, the interpretation is not open for speculations. So 2 or more users can go ahead and create a smart contract, and it can go up to 1 million users. Then all the contract terms are written as a code, and all these smart contracts are deployed on a blockchain. The moment they're deployed on a blockchain, assume that all the features that I just told you about a blockchain, they are imbibed in a smart contract, which means you cannot go out and you cannot make arbitrary changes into it. You cannot delete that contract out of ad hoc and all those stuff. So this is something where what happens is they imbibe all the things that are required or that are available in that particular smart contract. And then what happens is all these transactions start to get executed on its own. Let's say, just to explain this again in a little bit better fashion, let's say I want to go ahead and I want to start a chain of like 12 months payment with Prakash. And what I have to do is, let's say Prakash is giving you certain services on the blockchain, and maybe not on a blockchain, just he's paying. Let's say I have a rental space and he's renting it. So what I have to do is basically, so today if I want to go out and do it, and let's say I want to go and ask Prakash that you have to go and create a mandate in your bank account for the next 12 months, the rent comes to me on the first of every month, and Prakash goes out and does that. The problem with this is, even with all these mandates, it's not 100% sure that that the payment will come to me. Maybe at the time when this payment has to be processed, the bank is under maintenance, and this is something which I faced a lot. If your bank is under maintenance, it will not process the transaction, and because the time has passed, those conditions which have been built in that built inside that software of the bank will not work because the time has passed. So now I'll have to call the bank and say, hey, the payment has not been processed. Can you please do it again? So this was a small transaction. Let's say it's worth a $10 million transaction. So I'll need an escrow account so that the money is there. I need a lawyer services. But what all I'm doing here is increasing the cost of executing the transaction, but I'm not adding any efficiency. But with blockchains and with smart contracts, what happens is, because 99% of the time these blockchains are up, 99.9% of the times, chances that your transactions are going to fail is very less. I'll not say impossible, but very less. Second thing is, because everything can be the lawyer can be the smart contract, because all the things are written in a code. The escrow could be the smart contract, so I don't need an escrow services. And also, there's no bank charges and everything that I have to pay. All I have to do is pay is a gas fees, but my transactions are going to flow on time every month till the time the contract has money, or till the time for which I created that particular contract. So that way, what happens is, all that automation that is coming in through blockchain is also a very significant thing which is happening here. So that is where a smart contract works. And if you want to talk about a little bit of the use cases which are there for the smart contracts, first is retail payments. Imagine, and this is something which happened with is being used in Singapore today, which is something called smart payments. Now, in a smart payment, what happens is, let's say my younger brother goes to Singapore to study. He's in a college, and suddenly he calls me up and says, "Hey, bro, I just need $10,000 Singapore dollars for let's say paying a fees." So all I know is, I have to trust on his word, and I'll have to give him the money because he is asking for that, because he has to pay it for something else, for something in education. So I'll have to transfer that money. And that is something which is not smart money. Now, through this application of the smart money, what I can do is, when I'm sending this payment, I can do it through a smart contract. I can build a condition, and in the condition, what I can do is, I can say that through the smart contract and using the oracles, what I could do is, I could go out and say that only and only if this amount is being spent at an educational shop, then only make the payment. So let's say my brother actually wanted $5,000 for education, another $5,000 for maybe party. So he goes to a pub and orders whatever he wants to, and the moment he wants to go out and make the payment does not come out. It says it's not an educational institute, so you cannot make this payment here. So that is where what happened is, he had the money, but he could use that money only for the reason or the purpose for which he has been given the money. Now, if you think of these amounts and you think of these use cases, and you can apply them into the political world, where a lot of money, where you pay in the taxes, where only that money from the tax collection is being used for the things that are being told. Imagine how the NGO world could be evolved here. So a lot of use cases on the retail payment. Another thing is worry minimizing commerce. So today, if you have been using Amazon for the past 5 years, you would have seen that initially there used to be a very long process to ordering a particular thing. But while today, what happens is, the moment you click on buy now, there's a screen that pops up and says make the payment, and that's it. Within that 2 screens, you're able to purchase that particular thing. And earlier it used to take like a minute. Now, this is something where you use the sales funnel. If you learn about a little bit about sales, in sales, what happens is, you need to talk about, or you need to understand that for a person to make a particular purchase, you have to give him the minimum time to think. If you give him enough time, chances are he would change his mind and go back, and he would not even actually make a purchase. So imagine today, let's say Amazon has evolved, but imagine, let's say I want to give my girlfriend a $10,000 voucher from Myntra. So today, first of all, what I'll have to do is I'll have to create an account, and after creating an account, I'll have to add my payment services, I'll have to add my address, and then only I would be able to go out and issue a $10,000 voucher or 10,000 rupees voucher. When you talk about blockchains, you do not need to have an account. You do not need to add your bank account details and everything. Just connect your wallet and just purchase a voucher and just give it to it. So that way, what is happening is this sales funnel is getting reduced. And similarly, I mean, there are a lot of such use cases like parametric contracts, algorithmic management. Algorithmic management, again, I can give you an example. Let's say if you've ever been, or if you've ever driven a bike or a car or any two-wheeler, you have been controlled through those signals which are there, where people or a whole control room is sitting behind those cameras and operating the way the traffic moves. So that's algorithmic management, which can fully be deployed through a smart contract, and there's no need for actual human interaction there. So that way, so this is something which is where you can use these smart contracts, and that's about it. I think these were the two topics that I wanted to cover here. Happy to hear any questions if are there.
That was awesome, Aishwarya. I think reworking the basics is always a great exercise for even for those who are down in the rabbit hole. It's always fascinating to hear something like a deconstruction of what blockchain is about, right? So yeah, I think maybe I think we would love to hear some live Q&A right now, or if you want to drop in some questions, that's also fine. Can we have some questions right now?
Sir, I had a question.
Go ahead.
So you said that the transactions are pseudo-anonymous, right? That they can be traced.
Yeah.
So if we, I mean, in a hypothetical situation, if a company, does transaction through blockchain, okay, and if they happen to have some sort of some personal details of their employees, or maybe the people they are dealing with, maybe some other officials of some other companies, and they might be able to trace the transactions.
I mean, absolutely, this is true. But slowly and steadily, what is happening is, as the technology is evolving, there's something called zero knowledge proofs that are coming into the picture. Now, when we talk about zero knowledge proofs, what exactly is zero knowledge proof? Again, I'll just give you a very simple example here through a cave door analogy. In a cave door analogy, what happens is whenever you're going out and doing, so assume that I and Aditya, we two are standing outside a cave, and I know, so inside the cave there is a lock, and I happen to know the password. So there are two ways in which I can make you believe that I know the password. The one is I make you stand outside the door, or outside the cave, and I go inside the cave, open the door, and come out from the other side. The other thing is where what I can do is I can give you the password, and we both can go inside and check it. So the first one is a normal transaction, which is pseudo-anonymous transactions which are happening, where I'm telling, or where you can trace or you can track who exactly did the transaction. On the other hand, the other one is basically, which is a zero knowledge proof transactions or a roll-up transaction. Now, in a zero knowledge proof transaction, what happens is I actually would not go out and give you what exactly the password is. But if I go inside and I come out from the other side, it is assumed, or it is believed, that I would have known the password, otherwise I couldn't have come from the other side. So here what happened, the information did not travel through the blockchain, just a confirmation traveled. And this is something which a lot of use cases are being developed here for self-sovereign identities. Today, if you go to a hotel or a bar or a restaurant or something like that, and you have to go and book a room there, you actually go out and give your actual identities as a photocopy, which is very dangerous. What, on the other hand, these SSIs can do is they can store the data in a way where the data is not stored in a centralized place, just a confirmation. So let's say I go to the hotel and I tell him that my name is Aishwarya and this is my SSI identification number. All they do is basically they will go out and they will not take that identification. They will send a ping asking, is this Aishwarya Gupta? And from the backend, it will come. The answer will come. If the answer comes as a green light, the answer is yes. If it comes as a red light, the answer is no. So I did not give him any of my identity, but I made him believe that this is something what I know all about. So that is how this is being tackled now. Shreya, you have a question. Just let me read it. About blockchain security. Recently, we saw a huge Bitcoin raid by. So, how was the hack carried out? So, see, the hack was not on the blockchains. What happens is whenever you're talking about a particular exchanges, they act as a person or someone who has the custody of your wallets or your tokens or your bitcoins or whatever you have bought. In this case, bitcoins. Now, what happened to the Bitfinex case was someone was able to find out the private keys to access these bitcoins and move them. So that is what happened here. It was not that there was a hack or there was something where the Bitcoin was impacted. What the hacker did earlier, and they were able to steal or they were able to find out what the private keys are of the wallets where the cryptocurrency was stored. And when you give out your private key, what happens is you actually give out the way in which, or the access, or the way in which you can spend those Bitcoins. So this is where through which they moved that $3.6 billion worth of Bitcoins from Bitfinex to a private address. And after that, I think recently, a month or 2 weeks back, if I'm as long as I remember, there what happened was there is something where they moved it, and the moment they actually wanted to encash it through some ways, they were actually caught, and that is how this whole thing came to an end. A block, how can we visualize a particular block? So it's very simple. Assume you have a notepad. A notepad is a block. In a notepad, what happens is you're just writing all the transactions. If you have ever seen your dad or your grandfather having a full ledger book where he used to just write all those things in a particular place, that this is something which has been received in the shop or in the business, and this is how the expenses have been done. So that is what exactly is a block, where you are just entering all these transactions, and after entering all these transactions within that block, you are just actually going out and encrypting it in a way that nobody can actually go out and change anything inside. That's what a block is all about.
Sir, I had another question.
Go ahead.
Sir, how exactly did Bitcoin reach its current value in terms of the other currencies?
It's
Because
basically the game of demand and supply, I would say.
because the thing is, sir, it is not like here we have RBI, in America we have some other government institution that says that yes, we can use this as legal tender, and they give it the value. But here this is entirely a decentralized system. So from where is it getting the value? Who is authorizing it?
Let me ask
Who
you a
is legalizing
question.
it?
When you talk about a 100 rupee note or a 500 rupee note, what exactly gives it give it the actual value?
Sir, it's the institution that says that you can use this as legal tender.
In your line, just understand what you said. I am trusting the government that this 100 rupee note holds value. Correct?
Yes, yes.
There is no legal, there is no gold backing or everything. That is very clear, right? That is exactly what is Bitcoin. So so the value of a 100 rupee note is because you trust that 100 rupee note to have a value. Okay. The minute demonetization happened, that 500 rupee note, which had a value in your pocket half an hour before, now does not have a value. So this is the whole thing. You trust someone that it holds value, and that Bitcoin today is just holding that kind of a trust, that even without an intermediary in between and with a clear physical way in which the whole thing works, you are going out and you're creating, or you're having this whole thing very clear. The monetary policy is completely clear. This is the total number. The monetary policy clearly states how they're going to come out in the picture, and everything is crystal clear in quotes. So I can trust this even more, because in governments, what happens is they can take the fiscal, the governments can go out and take the decision, okay, tomorrow we have to print so much more money and the inflation is this and everything. They will decide. So you do not know. You are assuming that they're doing the work right. And tomorrow, let's say if the government fails, let's say this happened with Iran, I think, Iran or Afghanistan. So in Afghanistan, what happened when the government fell, the money that they had in their bank accounts turned almost to zero. So it's all about trust, I would say, how people are actually trusting a code instead of people who are actually going out and managing a whole economy.
So, sir, this means that the ones who deal in bitcoins are actually the people who make the bitcoin a sort of means of payment. You mean to say?
You can say that, yeah. A lot of people use Bitcoin as a medium of transaction because the transaction cost is almost negligible. If I want to go out and transact 100, if I want to send 100K Singapore dollars from India to Singapore, I will be charged somewhere around nothing like, but somewhere around 10 to $15,000. On the other hand, if I have to transfer 100K from India to Singapore through Bitcoin, all I have to pay is somewhere around $2-3.
So the transaction itself gives it its meaning.
Absolutely.
Okay, thank you. Thank you.
Any other questions?
Yeah, we have one more in the chat.
Go ahead. When you spoke about the zero knowledge proof, what can you say about the security measures? So speaking of security, my question is, can you explain how proof of work, proof of stake, and proof of assignment work as the security of the block? So these are not security mechanisms; these are consensus mechanisms. There is a difference. When you're talking about proof of work, when you're talking about proof of stake, when you're talking about proof of assignments, this is how the consensus is derived. Consensus means in the real world we have banks to ensure if I transferred $100 to Prakash, the bank is the consensus there. Bank says, yeah, Ishwarya had $100, let's deduct it and let's add $100 to Prakash's account. So the trust is created by the bank here. When there is no intermediary like a bank or something, these mechanisms are actually going out and creating that consensus, I would say. So that is how these things are maintained. These are per se, I would not say the security mechanisms, but more towards how you agree that this is something which is correct. And because these consensus mechanisms are very difficult to break, a byproduct is security. That you need to have 51% or more consensus on the Bitcoin network, which means you need to control 51% or more of the hash power, which is available on the Bitcoin network at any given point of time, which is very difficult to achieve, and hence it becomes very secure. On a proof of stake, what happens is in a proof of stake you have to have like more than 50% of the token value in stake to go out and overpower the network. Zero knowledge proof is also a way, you can say it's not a consensus mechanism per se, but zero knowledge proof is a technological upgradation. You can say just like let's say when a new technology comes in, let's say UPI came in. So UPI, the use case of UPI was you could send initially just 10,000 rupees to one another. Then slowly and steadily they had different products that came out in the picture. One was like merchant transactions and everything. So that way what happened, this a little bit this is just like a product, I would say, instead of like a security mechanism. This is a way in which you can do private transactions without actually involving or without actually going out and having any of those transactions being done in a way where it could be very easily identified. So the Indian rupee is backed by no. First of all, there is no backing. It's this was something which was done in 1960s. 1962. After 1962, there is no backing. There is no gold behind it. There is no security behind it. Nothing is there.
So yes, I think it's a very good questions there. I think part of it we'll also cover later today and as well as tomorrow. But yeah, I think we can take one more question. We will be talking about consensus today and tomorrow as well. We have another speaker for that. Any other basics like we can have it addressed here as well. We can take one last question.
Sir, I had one doubt.
Go ahead.
Sir, blockchain gives people the power, so it is not dependent on government. It is dependent on individuals. So isn't the government against this? Like because like people like ministers and all, they make illegal money and all. So basically, they'll be against this, like, because blockchain can expose all the scams.
One of the biggest hindrances for blockchain's wider adoption is this only, where I mean, you would have been seeing this a lot of people. So initially, people, a lot of government bodies and everyone coming out and saying that this is something which will disrupt the economy and everything. To an extent, if not kept in, if all those illicit transactions and everything not kept in check, yes. But definitely, this is one of the biggest ways in which all the transactions and everything could actually get the transparency and the visibility that is required. So definitely, it's a way in which it could challenge the supremacy of a centralized government, I would say.
Thank you, sir.
Sir, just one question.
Okay.
Sir, if all this, there is a cluster of computers that are involved in these in the blockchain, right?
Mm-hmm.
If any of them falters by any means, maybe intentionally or unintentionally, right, malfunctions, will the
So there
data
is
be
something
lost?
called no. So there is, so first of all, there were, like I told you on Bitcoin, there were 15,000 nodes. 1 false, 2 false, 3 false, 10 false, 1,000 false, no problem. There's a formula called in Byzantine fault tolerance. This is something which where you have 2n plus 1. So if 2n plus 1 of the nodes which are alive are actually not faulty and are working in positive way in which they are not actually going out and having a negative impact, or they're not colluding, the blockchain can remain intact. Which means if there are 3 nodes left at the end, the Bitcoin network will still run. I think that's it from my side. What about the high implementation costs by the companies? Absolutely, a new technology will always cost you more. And the best way to adopt these things are once the private transactions come into the picture. You can definitely go ahead and adopt those solutions. They will not cost you like a lot. They would barely cost you anything, and you can always implement those public blockchains in your solution. The private blockchains will cost you because you are maintaining and creating the whole ecosystem for your own self. The transactions cannot be reversed.
So does this mean that companies can form their own cryptocurrencies?
Companies can form their own cryptocurrencies. Anyone can. You can. Within 30 minutes, you can.
Oh. So, but how does it? I mean, I'm still not able to wrap my head around the value that it has reached right now.
Yes, it is about trust. You can, like I told you, you can create a Bitcoin, but if nobody trusts it, its value is zero. If people are actually able to trust a code, and why not to trust a code which has clear ways and clear things and clear guidelines as to what exactly and how exactly things has to be done. So
don't
Mhm.
all the cryptocurrencies have the same security standards?
I would say no. There are different ways in which the blockchains are developed, and based on which blockchain you are and everything is there, that security is maintained. So Bitcoin has its own ways in which it maintains the security. Ethereum and the smart contracts running on it and the projects running on it have their own ways of security. So it depends upon which blockchain you are on.
So shouldn't the newer cryptocurrencies be better than the older ones? I mean, shouldn't that cause a shift in the
I mean, it has to depend upon what exactly is the new use case, or what exactly is, or how exactly that is solving the issue, and what exactly the use cases or the utility that is getting created. So all those things will be taken into consideration in that format. So you cannot say if a new cryptocurrency is created. So that's a very standard line which will never hold true, because a new cryptocurrency could be created for a scam. So its value should be zero. So it will always depend upon that. I mean, there are a lot of questions I completely understand when you talk about it, and that is why I dropped a link as well. So there are courses which I've already created, and you can go through them as well, which are very basics. Like the examples that I've given you right now, those are the kinds of examples that we use to make you understand. and there you can go ahead and do it. I've put the link in the comment box itself. You can just take a look at it, and if you have any questions which are there, I think I'll have to leave because I have a meeting. You can always go ahead and tag me on, or you can DM me on Twitter, and I'm more than happy to answer your questions. So that is my TT handle. So Twitter handle. So you can just connect with me. And that's it from my side, I think.
Yeah, thanks a lot, Aishwari. Yeah, it was a pleasure having you. So yeah, I think right now we can extend it slightly. So in the same theme with Sachin here as well. And yeah, I think we will have a few intermittent Q&A in between as well, and similar questions before the next speaker as well. Yeah, Sachin, are you present?
Yeah, hi Prakash. Hi everybody.
Yes. Yeah, you can go ahead now. Yeah, let's start.
Yeah, so just start with an introduction. I graduated in 21 as a computer science engineer and took the decision to hop into blockchain and full-time Web3 as we call it, and take a job as a blockchain developer and not go for campus placements. And I think that's blockchain is what excites me currently. I'm working as a blockchain developer in Persistence. So Persistence is one of the largest blockchain companies in India. Before that, I did my internship in Nord Finance, which was a company that was developing decentralized finance protocols on Ethereum. So yeah, that's pretty much about me.
Awesome.
I think, I'll start with giving everybody, I hope that everybody here is an engineering student. So, from an engineer to engineer, I would like to give a small perspective on how you should think about the Web3 technology as such, in case you're looking to dig a little deeper into it. So to understand the reason why we need blockchain, we really look how the technology of computers have evolved over time. So if we go all the way back to 1960s, so 1960s was the time when uh, all the people who were developing computer systems came together to see how they can progress with it. Before that, the first example of computer, as you guys may know and have watched the famous movie, was to decipher the Nazi codes. So the cryptography behind the computers was essentially a military technology, and it was all the people who were developing cryptography, which is the root of computers, were really involved with the military operations of every country. And when the World War II ended, all of these guys came together and then they started developing computer system for non-military uses. So if you look at 1960s, the computers used to be a size of the room. And IBM once famously said that the computer sales would not be more than 5 computers a year. So what happened then? One major technological revolution that came in computers was SQL. So before SQL, the way you retrieve data from a computer that was very huge was you move the magnetic tapes. So there were punch card and magnetic tapes in computers in those days. And to retrieve a data, you move the magnetic tape number 3 forward by 7 feet. And that wasn't feasible, right? That just made things more difficult. If you have a book of telephone directory, you would want things to get easier, not more difficult. So SQL was a revolutionary tech that brought the technology to everybody because it allowed to have a data set in a sense, and then you can easily traverse through the data set. Obviously then Apple came in the 1980s. We had the microtech, and this is the second phase of the computers. But the second revolutionary aspect was the internet, obviously, because what it allowed was to us and visualize it in the sense how the data is evolving. So we move from singular atomic data to the network relational data. Every website had its own database. But but this really didn't, you can say, evolve off because there was no security in the data. So in 1994 to 1995, people started wondering that, how do you securely transmit the data to the internet? Because you cannot use credit cards. So then they started with encryption. And you really see that e-commerce boom started in 1999 to 2000 because that's when encryption came in to the internet, and that was the second large revolution after SQL, a simple encryption that allowed credit cards to be used on the internet. So that was the second massive shift. uh, then so now we had the singular atomic data, then we had network, internet, and relational data. But if you look at internet, the database was never exposed to the end user, and there were a lot of firewalls and guards before you interact with the data, because data is very complicated. And every website had its own data. So you want to fill your address in Amazon, then you also have to fill your address in Flipkart, and to all the other 100 websites you have to fill your email address and the same data again and again, because the data is not shared. So what Bitcoin essentially did was it brought the data and the network together. Now you had a single shared storage, and everybody had the same sense of reality in terms of network storage. So in a sense, blockchain and Bitcoin is just evolvement of how we store the data. And then Ethereum came along, and as Aishwari just explained, you have smart contracts. So what are smart contracts? It's just storing the code on that shared database, so that now everybody has the same data, everybody has the same code, and everybody has the same result. So as an engineer, you should look as just how the data is evolving in a sense. And uh, yeah, the first use case of this shared database was essentially Bitcoin. So Bitcoin is a use case of this shared database technology. Uh, and this shared database technology is what is called blockchain. So I hope that kind of gives you a perspective on how to move forward and think. Uh, but yeah, I'll be happy to answer any question if you guys have on taking up career in Web3 or anything related to blockchain.
Yeah, and one more thing is, so I know we had some questions on the valuations and everything, right? So this is like a fundamental, think of this as like a fundamental ecos, right? So I think it's important to understand the concept first before making any judgment calls. At nowhere at this point we are giving any financial advice. I don't think anybody can give financial advice. But what we can still do is at least understand the tech, right? Because we are still way too early. You might think, okay, so much valuation has changed, but I think none of that matters. It's about how you want to make a difference to any application that you use. It's only a matter of time. At least the tech is going to be adopted. I think even the government at no point have said that the blockchain is a wrong tech, right? We always get teams funded. There are always going to be use cases around it. They just want the people to have much familiarity with it. That's why we still have this regulations trying to come to terms with it. So yeah, that's the basic we want to give about. So if you expect us valuations, it can always be there. You don't need to think about it at this point. But if you are able to understand the basics from the speakers, and I think that will make a lot of difference, because the information always gets updated every 2 days. So yeah, I think, but if you get the basics, it'll be very rewarding if you want to take up a career. But yeah, that's a very long-term call. You can try to understand the tech, and eventually you will be among the industry as well. Yes, any other questions you have, a Sachin? Then we can slowly move into a bit of interactive session for the next 20 minutes or so.
Sir, I had a question. So,
yeah, go ahead.
if we were to start with, understanding the blockchain, what sorts of concepts, according to you, would be central to it?
All right. Yeah, good question. So there are two parts of it. One is the development part, and the second is understanding the ecosystem. Uh, so obviously you start with what is a blockchain in a sense. And I think the best video for it is 3 blue, 1 brown. I'll paste the link in the chat after it, but it's 3 blue, 1 brown, and it's a 15 minutes video which explains what a blockchain is. The second is starting off with developing applications on blockchain. The easiest route to take is smart contract development, for which Solidity is the language which is the most common on Ethereum. So I think, yeah, after you understand what a blockchain is, you start learning Solidity. That's the easiest path to onboard as a blockchain developer. And the second aspect to it is understanding the ecosystem. So because a vast majority of the applications are, yeah, thanks Prakash for posting it. So a large majority of the ecosystem is focused around finance. So you need to understand how the finance protocols are working on blockchain. So there's another channel called Finematics, which helps you understand how these protocols are working. So because you also need to understand the working of these protocols so that you can develop applications that interact with these protocols. So yeah, Solidity and ecosystem, learning about the ecosystem. So yeah, two questions here. Are browsers like Brave browser using Web3? Yes. I think Brave is the best example on how you introduce cryptocurrencies and blockchain to a native user. So they use a blockchain for their cryptocurrency called BAT. Their cryptocurrency is on Ethereum. So for for the cryptocurrency they use Web3. So you're asking of what exactly are they purchasing when a person purchases cryptocurrency? So this is a wide question because anybody can create a cryptocurrency and then add a utility for it. So so let's take example of Brave browser, which has a cryptocurrency called BAT. So if you want to advertise on the Brave browser, you have to pay in BAT. Let's say, Facebook wants to put ads, Adidas wants to put ads in your, just like you see ads on when you're browsing Google Chrome and Google and etc. websites. So you see Google ads. Similarly, if somebody wants to advertise on Brave, they have to pay in BAT token. And as a user, when you see those ads, you get 40% of the revenue. If somebody paid 100 BAT to advertise on the Brave browser, and as a user, you get 40 BATs for viewing the ad. So here the utility becomes, because if more and more users are seeing the ad, more companies want to advertise on the Brave browser. If more companies want to advertise on the Brave browser, they have to buy more BAT. So the demand for the BAT cryptocurrency increases, right? And when the demand for the cryptocurrency increases because you have to pay in BAT to advertise, the price of the BAT increases. So that's one utility. But similarly, there could be 100 different utilities for 100 different tokens. So they are DAOs. DAOs are basically decentralized companies. So some cryptocurrencies allows you to have a vote in that decentralized company. Let's say there's a DAO which has $1 million in the treasury, and somebody else comes and says, if you give me $100,000 from your $1 million treasury, I'll create a project and I'll give everybody in the DAO or everybody who has the DAO token that allows you to vote some share of the equity. So your DAO token allows you to vote if you want to give 100K from the treasury or not. Let's say there's 60% vote that yes, 100K can be given from the treasury. So DAO token allowed you to vote. The more DAO tokens you have, the more voting power you have. And so when the 100K goes to that person and he creates a project, and everybody who had the DAO token gets the equity of that project. So in a sense, I just giving you a perspective. This is also what is happening. They could be the utilities are up to how you make of it, and just innovation at this point is just people are brainstorming and creating utilities. How does blockchain work with respect to real-time updating of data in the nodes? All right, so this is a very complex question to explain without a presentation and without building up the basics of it. But so you should understand it in a sense that of a linked list, in a visualized blockchain as a linked list, and every linked list connects to the next linked list, and every linked list has a data. To exactly answer this question, I have to clear more fundamentals, but that will become like a session. But when a miner mines the latest linked list, it broadcasts it to the network, and there is a lag, but the lag isn't significant enough because there's a block time. Bitcoin has a block time of 10 minutes, and that broadcast to the network when somebody adds a linked list to the blockchain is within microseconds. So there isn't any lag as such, but this is a very good question about when.
Fundamentally, a few of the, at least that Bitcoin is like the first gen crypto, right? When you look at the second gen ones, there is something called like the why you have a gas fee is to make sure that you want to accelerate the transaction. That is possible, right? So that if you don't want any lag, there is a consensus mechanism that dictates a specific gas price. So think of it like search pricing, right? If Uber is very cheap today, will it always be cheap today? Probably not. But if you want to take a time, if you want to go from point A to point B, you're going to pay the search pricing, right? So that is similar to how it also functions in use cases like Ethereum. So yeah, a lot of modern generation cryptocurrencies, at least some of them have this mechanism where you can pay the search pricing to make sure the transaction goes a bit faster. But yeah, it's something that keeps updating every single week in terms of consensus mechanisms. But in a nutshell, there is a standard lag for each cryptocurrency, but you can always make sure that if you want to accelerate, you can pay the extra fees as well.
So to what just now Prakash sir said, I just want to engrain it in my brain. So what he was trying to say is that you can pay extra or do something else, as in you can put an attribute to your block to say that I want this as a priority. Like, is there something like a priority basis, like my block can go faster than someone else's, like that?
All right, so yeah, you are partially correct. So you don't send a block, you send a transaction. And let's say all of us in this call send a transaction, and the block consists of 1,000 transactions. I'm just giving an arbitrary number. So 1,000 transactions are included in the block, and the block itself is validated and mined and added to the blockchain. As I told you, imagine it like a linked list. So the block itself is added to the linked list and contains 1,000 transactions. So you can pay a priority fees for your transaction to be included in that block. And yeah, that is correct on Ethereum.
Got it. Thank you.
Awesome. Yeah, that's good. So I think we will have a bit a bit more, 5 minutes, more minutes of possible questions. Then if I think we can also have the next speaker in, and then we can return to a bit of moderation as well. So yeah, we can have a couple of more questions. Then we can ask if Srikanth would like to go next as well. Yep.
Apart from that, if anyone is interested, if you dig deep into blockchain, are interested in getting an internship or anything, I'm sending out my Twitter handle. My company is hiring interns. I am also creating a DAO called Wolf DAO. So we are in partnership with the blockchain school, and the DAO works in a sense, I think is the best way how you can learn blockchain development, with kind of an open source community, and just develop products, and not only develop but launch it on mainnet, get a part of equity of the product that you're launching, and just interact with a lot of people. So yeah, in case anybody goes ahead, learns blockchain, you can follow me on Twitter, and my DMs are always open.
Awesome. So we'll right now go into a bit of the blockchain fundamentals a bit further. Then we can circle back on more questions from any of us. So yeah, Srikanth, would you like to go next? Or actually, if the organizing team, do you guys have any specific questions you want to ask the speakers?
Nothing as of that, sir. And it's been going great and very interactive.
Okay, awesome. That's great to go. Yeah. Srikanth, if you're ready, you can always take up.
Sure. Hope everyone can see my screen.
Yes, it's visible. Yeah.
Hello, everyone. I'm Srikanth. I'm a full stack developer by day, and I'm a blockchain mentor by night. I have over 7 years of experience in the software industry, where I'm juggling both parts of Web 2 as well as Web 3. So, I have seen how things have moved. I've started out my career as a backend developer, then as a full stack developer. Later on, now I'm also being a mentor, where I get to teach professional students as well as professionals on blockchain. Okay, so this is a very short and understanding of what blockchain.
Can you check the audio bit? I think.
Okay. Just a second. Is the audio better? So I hope.
Yeah.
Okay.
Yes, sir. It's much better, sir.
Yeah. Thank you. Thank you. Let me just wear it like a mask. Okay. So now, to talk about blockchain fundamentals, what we're going to learn here is a little in depth of what we learned from Ashwari. So a little more on technicalities, little more of exploration that we are going to do. Okay, so this is a very short introduction about me. If you want to contact me, I'm available on LinkedIn. This is my LinkedIn handle, and I'm not quite active on any other social media platform, so you will not find me anywhere else. Apart from that, what up? The 50 or 60 of us that we are sitting in this meeting, we can think of us as a blockchain. Imagine each one of us has a responsibility in a blockchain. So you are a part of the blockchain. You are one node. Let's assume, what is blockchain? Blockchain is a peer-to-peer network. It's not a centralized network. It's a peer-to-peer network where not one single entity that has complete control over everything else. It is a system where everybody puts in their part. So all 50, 60 of us, or everyone who is on YouTube watching this live is part of our blockchain network. Let's call this as a ocean blockchain. Okay, this is just an example, or a Bitcoin blockchain. All of us are individual nodes. We are all are individual nodes in this blockchain. Each of us 60 are 16 nodes in this. Now, okay, let's say we are nodes. What do we do? So not all of us are equally responsible. Some nodes take extra responsibility. Okay, they become a minor nodes. Some take lesser responsibility, may run a client node, and depending on their capacity. Okay, so there is no hard and fast rule that if you are a node, you have to take this responsibility only. You can take big, depending upon your capacity, you can take whatever role you want to take in the blockchain. Next, now, okay, I've taken a role in this blockchain, and if you, let's say you have become a minor node. What is the purpose of a minor node? There are minor nodes and there are other nodes also. Then now coming to this special concept of minor nodes, what do they do? So whenever any one of us starts a transaction, let's say I'm sending a transaction to Prakash. Okay, this transaction initially will be an unverified transaction, just like our Google Pay payments or Phone Pay payments. When we do the transaction, for a few seconds, this shows a loading period, and in that duration, it is unverified. When the bank server says that yes, this person has enough money in his account, and then says yes, this is a verified transaction, then we see a tick mark on our screen that our transaction is verified, and it has moved to our friends or whomever we were sending the money to. The same way, when we start a transaction on a blockchain, all of us in this network, someone transfers, that is, for example, I am starting a transaction to Prakash, and this transaction initially will be an unverified transaction. So now coming back to the concept of minor nodes, this minor node will, when he receives this unverified transactions, he is going to take this transaction and verify it. What does he do by means of verifying? He will check whether do I actually have $100 in my account to transfer it to Prakash's account. And also it will do additional checks whether this is a valid transaction or not, whether did I really tell I want to transfer 100, or whether did I tell to transfer 200, did something happen over the network. All these verifications it will do, and it will create a block. So it will put all this transaction, my transaction, your transactions, Sachin's transactions, all transactions it is going to take and put into a block. How much does this block will fill? As much as it's possible. So each block is like a box. Let's say it may hold 1,000 transactions, only 1,000 transactions will put. If they're left over, they will be taken in the next iteration. Okay, so he will put all this transaction into a block, and he has to do one additional task with this. What is the additional task he has to do? That is to solve a crypto puzzle. He has to solve a crypto puzzle. Now, to give an equivalent of crypto puzzle is a Sudoku puzzle. Like most of us would have solved a Sudoku puzzle in our lifetime, right? So how long does it take to solve a crypto puzzle? If it's a really hard one, maybe, and even for an expert, it would take around 10 minutes to solve a crypto puzzle, right? Isn't it? So he takes around 10 minutes to solve the crypto puzzle, and then when he gives it to you, yes, I have solved this puzzle, verify it. How long will you take to verify it? You will take few seconds, right? You just check whether there are is 1 to 9 in each horizontal rows, vertical, and each of the boxes. That's all you do, and done. You have verified in seconds. The same kind of work the miner has to do. He has to solve a very complex crypto puzzle in addition to verifying the transactions. Only after he has verified these transactions and solved this crypto puzzle, he has created a new block. Okay, he has created this new block, and once he creates this new block, he will propagate to everybody else. Let's take, for example, Sachin is our minor node in this case, and he has created a new block, and he is going to transmit to everyone else, every one of us. And we receive this block, and we also verify whether the same Sudoku puzzle verification we also do, and then add it to our blockchain. This is how any new block, any new transactions comes into the chain gets added to our blockchain. Okay, it has to be verified, block has to be created, and that block also has to be verified. Then that transaction becomes a valid transaction and it sits on the blockchain. Until then, it's an unverified transaction. Okay, so coming back to the basics, what is a blockchain? Blockchain is a shared, it is shared, right? We all 60, 70 or more of us are sharing this blockchain. Students, most of you, it's 4 basic operations. One is create, read, update, and delete. Any programming language you start to learn, you learn these 4 operations: create, read, update, and delete. But here in a blockchain, you can only read and append. You cannot delete. There is no option to delete a transaction once it is added to the blockchain. Okay, only reading and appending, add new transactions to it. Once, let's say there is a mistake in your name. Okay, my name is something and there is an extra H or extra I or something in my name. Now, in a traditional database, what happens? That existing record will be deleted, and on top of that, this new spelling will be overwritten. But here in this case, it does not happen. That old data will remain, but it will be linked to the new data. That is, it has been updated to this. The old record will remain as is. It will not go away. Okay, that is what the immutability means. How do we achieve immutability in this? It's a complex process, but let's see if we have time, we can go over it. Okay, so main features of a blockchain. What are the features of a blockchain? Just as we discussed, it is a decentralized peer-to-peer network. Can you give me an example of a peer-to-peer network that you have come into picture, have been part of? It's you can say it's torrents, right? So torrents, the BitTorrents where people would download movies and games for free. So that was a peer-to-peer network. That was a peer-to-peer file sharing network. So there was no censorship over there. There was no centralized authority over there. It was all distributed people, providing the network capacity, providing the internet capacity for you and everyone to share resource. That was a beautiful example of peer-to-peer network that we know of, right? And also transparency. It's publicly shared. Transparency means anybody can see what is happening on the network. Even you can see right now. I will show you in a few seconds. I will show you the transaction that is happening on the blockchain. You don't need a login. You don't need to log in. You don't need to ask for permissions, anything. You can see the transactions that are happening. Okay. Immutability, just like we discussed, it is as if it's written on stone. You cannot erase it. It has to be only updated. Another very beautiful example of a blockchain is this book. Okay, the book that I'm holding in my hand is a blockchain. So what does the blockchain contain? What does it contain? Blocks. Just like blocks are there, a book contains pages. Each page is a block. Okay, each page is a block. And what does this each page contain? Each page contains transactions from Prakash to Shrikant to Sachin to Aishwari. All transactions are there and are recorded. Okay, and then just like this page number 2 is connected to page number 3, page number 3 is connected to page number 4. Blocks are also connected to each other. They are connected in a linked list fashion. So now the other important thing is, it's not just me holding this copy of the book. All of us in this network have a copy of this book. That is the beauty of the blockchain. Let's say if my node goes away, means because of some internet or power outage in my area, my node goes down. You and everybody else will be able to keep the network running. If someone comes in and asking for a resource or wants to add a new transaction to the network, he will be able to do it with the help of you. So there is no single point of failure in this case. That is the beauty of blockchain. That is the beauty of peer-to-peer network that we get, advantage of peer-to-peer network that we have. And one more thing, just as I said, here these pages are immutable, as if they are not pages made of paper, they are made of stone. They are not writing with a pen, we are carving on these pages made of stone. Okay, we are carving on top of them. There is no editing. There is no updating of system. We have to always append. So if something is wrong, it's there. It's written. You cannot change it. You can only append it to. So that gives us one core feature is core benefit that we get is it is immutable. So it is tamper proof. So let's say somebody, you can trust the information that is available on the blockchain anytime. So you don't have to worry about something. Okay, with 100% certainty you can say that this particular transaction is a verified transaction, and you don't have to worry and do an auditing. Go ahead and do separate auditing of this particular system and checking all these things is not necessary. You can see this itself is the proof that this is a valid transaction or valid activity or valid asset transfer. It could be anything. Transaction need not be just money transfer. It could be an asset transfer. It could be you're transferring your land properties to somebody else. You could be voting to someone else. Everything is a transaction in a blockchain. So if you're buying a NFT, you're buying a laptop charger, something you're buying, everything is a transaction here. Clear? Now, how does a blockchain work? Just like we all did verified a transaction right now, the same way the blockchain works. So a transaction originates and it comes to this. This is us. All of us in this meeting are the nodes of the blockchain. So this particular transaction starts propagating. It will reach one node, then it will reach other node. It will reach every node. By then, in these nodes, there are certain nodes that are minor nodes who take this responsibility of creating the blocks. This middle node that we see has taken the responsibility of creating the block. He has created the block here and he is broadcasted to everyone. Yes, hi guys, I've created the next block. Right now you have till only 99th block. I've created the 100th block. Please accept my block. Right? So when everybody accepts his block, that is when they verify. All of us will verify and accept the block. Nobody is going to accept the blocks without verification. So once everybody verifies and accepts this block, that box becomes a valid block, and all the transactions in that block becomes valid transactions. That is when you see that tick mark on your app. So when this is done, this is added to, everybody starts adding the new block to the chain. Okay, then you get the tick mark. Next, contents of a block. So you all already know that what the block contains. It contains list of transactions, not just one or two. It could be many transactions, thousands of transactions it could contain. Plus, it will also have block hash, and it will also have the previous block hash. Three things it is going to contain. One is the transactions. What is hash? What is hashing? What is previous block hash, current block hashes? So hashing, to say in simple words, it's like a digital fingerprint it's like a fingerprint of things. So if you write some word and you convert it to hash, it will always result in that same hash as long as you provide the same input. And hashes are not reversible. It's a one-way function. So all the transactions that are in this block, all the transactions that are there, they are taken together, and the previous block is also taken into consideration. These combined, we are going to create the block of current block. Sorry, hash of the current block. When we create the hash of the current block, what happens? Its fingerprint becomes very unique. Nobody will be able to alter it. If any single small full stop, comma, uppercase, lowercase, any change that happens in the transactions or in the any of the data that was consumed to create the block hash, the whole block hash varies. It looks totally different. It does not look anything similar to what we had initially. So that will help us to have a tamper-proof system. So because of this hashing that we have a tamper-proof system. So nobody will be able to edit transactions. Once a block is created and added, no one will be able to remove that block and add some other block in that place also. Hope I'm clear. Next is the chaining of blocks, right? So we saw that there is block number 10, and then there is block number 11, then there's block number 12. So the root hash of block number 10 becomes the previous block hash for block number 11. The root hash of block number 11 becomes the root hash for block number, sorry, previous block hash for block number 12, right? So this is similar to a linked list. It's chaining. So these blocks, individual blocks, are created and are chained one on top of the other. So that is why we call a chain of blocks as blockchain. Okay. Next is a infrastructure of blockchain. If you want to see how blockchain has evolved compared to our current existing industry internet, we can compare with these two stacks. So our existing internet started with a TCP/IP protocol, these network level FTP, HTTP, DNS, right? So where someone has to lay cable. That was the killer innovation at that time. So you need not have to write a letter and put it in the post box that the postman will take some months or some days to reach to your destination. You can write an email on your computer sitting at your home and send it to your friend, and it will save you time, it will save you money. It was much more efficient than our existing system. So the efficiency that we saw in this system was the same efficiency that we saw in the innovation of Bitcoin also, that we'll start compare it in some time. So next is the application universe. So the email was the tipping point, then came the application universe, where what we are doing right now, streaming videos, streaming Netflix, Amazon Prime, right? Data sharing, cloud computing, all of this came into picture on top of that. So, but to all of this application universe to happen, we needed the email to be there, right? So that spark had to come, and on top of that, these applications that we built, it was a gradual incremental innovation, step by step, and that has led us here today. And that is the internet that we know as of today. That is the information transfer. It is an innovation in information transfer. Now what we are going to do with blockchain is a little, it's not a innovation information transfer, it's an innovation value transfer. We started with the protocol. So protocol layers are the rules, the basic rules that are laid out for a blockchain, for a network, peer-to-peer network. Then comes the network. In network also there is Bitcoin network, there are miners, staking pools, full nodes. These are all the miners who are allowing the network to exist and maintain it. Third thing, the tipping point, that was the first innovation we all know is Bitcoin. So Bitcoin, it did not become an all-night success on the day it was innovated. It was created slowly over the course of time. People realize its value. Today, if you want to transfer money over any of the traditional banking system overseas, you have to wait at least 2 days and give a much higher percentage as commission for the existing intermediaries who are involved in transferring the money. So you would have to wait at least 2 days. But with Bitcoin, you can send transaction in 10 minutes to anywhere in the world, right? And at a fraction of the cost. So this is what the tipping point of this was the utility of Bitcoin. Someone was asking why Bitcoin has so much value, because it also has purpose. It's because you can transfer assets, transfer money across borders for the fraction of the cost. That has value to it. And one more reason why Bitcoin is so much value today, it's been over how many years? 2009. So 13 years it has never been hacked successfully. So that level of security it has provided to us. So that is one of the core reasons why we see Bitcoin's value is so high. Any blockchain that has sustained over a long term will have an intrinsic value, because it's very difficult to attack these blockchains. You can attack, but to succeed in attacking and do a double spend or do a 51% attack is very difficult. So whoever has stood the test of time has a higher value today. Okay, and also utility is important for this to have a higher value in the market. Next is the application universe, that is the smart contracts, distributed computing, tokenization is all happening on top of this. Smart contracts, writing dApps for NFTs, DeFi protocols, all these, and DAOs, right, that we have been discussing, all of them are in the application universe. And this is the internet of value that we are building with the help of blockchain and other distributed technologies. Any questions?
Yeah, I think we can take some questions.
Yes.
You guys would have had some doubts, right, so far. So Srikanth has really beautifully explained how the entire scaffolding works, right? So that's think of it like a building blocks of sorts. So no concept is learned overnight, but this basics is something that's going to stay everlasting, right? Despite whatever network updates happen, these are like basic blocks that will stand true at any point of time. So if you have any specific questions to ask, you can definitely ask now. We have a question on the chat. Srikanth, you want to take that?
Okay. Stop sharing. Yes. What is the difference between a node and a block? So node is something, node is a computer. Your system, your laptop can become a node in the network. You and your friend have connected through a LAN cable, then your laptop becomes one node and your friend's laptop becomes the other node. Block is the data. Block is the transactions that are verified and bundled together in an unbreakable format. You are creating it, a block is created, you cannot shake anything out of it. It's sealed, done and dusted. You cannot alter that block. So that is data. That is the data that is sitting in your node. That is the data that is sitting in your friend's node. Okay, it's a record. It's a 1 MB file or 2 MB file that you can think of that is sitting on your laptop. Any other questions?
Excuse me, sir.
Yep.
Yeah. So my question is about like you compare blockchain to these UPI systems of transaction. Basically, you said that there's that loading period, right? Can I call that like a buffer period where the block is like waiting in a wait list or something like that?
Block is not waiting. The transaction is waiting to be verified.
Yeah. So how long does that take?
Okay.
The waiting of the transaction. Yeah.
Okay. It depends from one blockchain to other blockchain, and it also depends on how much money you're ready to give as fees. So if you're ready to give very small amount, and I would have very less incentive to add your transaction over somebody else who is paying me higher money, right? So let's say Ujjwal transaction is giving me 10 rupees, and there is also someone else who is paying me 11 rupees. I would pick the transaction who is paying me 11 rupees over the one who is paying 10 rupees. So it's like that. If you want your transactions to be added a little faster, you would have to pay a little extra gas fees to for the miner. So now as I've explained, the very good question, Ujjwal. So as I've explained, all of us are a node in this blockchain, right? Everyone is a node. And why would I be a node in this? I don't want to participate in this. What's the benefit I get? I have to take all this responsibility of verifying the transactions, doing all this. Why would I do it? Right? You would do it because you're incentivized. So now let me share something. So this is a Bitcoin block explorer that we are looking at. Okay, so we are going to explore the Bitcoin blockchain, blocks in the Bitcoin blockchain. So I'll take one, so the latest block, that is, I'll take 723890. This block I'm going to take, and I'll click on this. So now you see As a miner who has mined this block, he has got a mining reward. So this is a completely incentivized system. So anybody, any participant of the network who is, why would anyone want to become a miner node? Because of this. Because if the block he is going to create is verified and added to the blockchain, then he gets a mining reward that is worth of 6.25 bitcoins as of today. So that is a lot. Don't take out your calculators, take out your calculators later, but it's a lot of money. Plus there is a very small amount of fee reward. So fee reward also he'll be getting. This is the reason I would, okay, if I'm getting this incentive, I'm not going to, simply give my processing power, internet, electricity for this, something called blockchain. And why would I do it? Now you're saying I'm going to get money, I'm going to get tokens, then I'll do it. So I'm not doing anything for free. I'm also incentivized through this. This is a model that runs based on incentives. Okay, as there is no centralized authority to take care of the activities that are happening, there is no individual, there is no single authority, right? So that is why everyone has to share the responsibility. Whoever is there to share the responsibility, whether it is decision making in case of DAOs, whether it is transaction solving, transaction verification in case of these Bitcoin blockchains, they will be rewarded for the responsibilities they are handling as per the network. So the rewards may be differ from one blockchain to one other blockchain, and the activity that you have to perform will also differ from one blockchain to other blockchain. Sometimes some will pay you for providing your storage space, some will pay you for providing your processing power of the laptop, some will provide you for your attention. That is what basic attention token is, right? So they are going to pay you for your attention. They are going to put some ad and you view it and you earn money from that. So this is all incentivized. Every person participant is also incentivized to participate in this network, and people who are validating, who are taking care of the network are also incentivized by earning, by the rewards, block rewards, or the some transaction fees that they get. This is why they're motivated to keep the network running. Otherwise, there is no motivation for anyone to run a totally decentralized system. Correct?
Yes, sir. Just a small add-on question to that.
Sure.
Can you list out a few factors which will change how much incentive a person receives? Because when you hear about these miners, Bitcoin miners, they have full-on setups to do that task. So what are the factors, basically? Yeah.
Okay, so the mining rewards vary from blockchain to blockchain. Okay, it's not going to be consistent. Some blockchain has some kind of reward mechanism, some other has a different mechanism. Coming to example of Bitcoin, or how to set up. So if you want to become a miner, what you have to do right now, it's very difficult to become a miner. But if you were in your primary and that time you had your laptop and you had started mining Bitcoins, you would have been able to mine Bitcoins from your from your childhood only. But now it's not possible to mine Bitcoins on our laptops. It's very difficult. You have to have specific hardware for it. So you can mine Ethereum with GPUs. Your CPUs cannot handle this. GPUs can handle Ethereum mining. Okay, then to mine Bitcoin, there are some specific hardware, some specific integrated circuits called ASICs. If any electronic students is watching this, they would know what ASICs are. They're application-specific integrated circuits. Okay, application. Their only purpose is to mine Bitcoin. That's the only purpose they have been built. Okay, they have to buy those processors, integrated circuits, and create rigs. Maybe 6, 10, or much larger than that, and start mining it. So you have to have a mining software, maybe, and also even if you create a mining rig of 6 to 10 ASIC systems, you would have to have a cooling system. You have to have a electricity, internet. All this has to be provided. Plus, you will not be able to create blocks as alone. If you alone want to mine a Bitcoin block, you will not be able to do it because the mining is very, very competitive right now. So you have to, now that you cannot compete against others, what you will do is you will join others. So you will create a mining pool, and your friend will create a mining rig, and your friend will also create a mining rig, and you join the third person. 3 people, you're going to combine all your mining resources together, and you create a mining pool. With these mining pools, you start to mine, and whatever the reward you are going to get, you are going to share it among each other, depending upon your agreement, like this.
Sir, I had a question.
Sure.
So why does it get so difficult as time passes to mine the bitcoins?
It so it may to answer your question, it can get easy also. It can get easy also. But the thing is, there are more people involved in this, right? So let's say there are 10 people who were only running this network, and the total processing power. I have a 8 GB RAM, you have 8 GB RAM, and there is all of us have 8 GB RAM processor. Then the combined processing will be like 80 GB processing, right? Now, with 80 GB of processing, someone will be it would take 10 minutes to solve the solve the crypto puzzle. But now new people started getting added, so there is no limitations on when you can join, when you can leave. You can join the network anytime you want, you can leave the network anytime. There is no restrictions on that. Okay, so when this happens, many people join. So okay, now you 10 are earning money, I also want to earn money. So then they will join. Now become instead of 80 GB processing, they have 160 GB processing. Now there are more people, but if because of more people have come into picture, then it becomes faster to mine the block. So when it becomes faster to mine the block, there is something called an intrinsic mechanism in Bitcoin protocol called difficulty adjustment. So what you see here, this thing, right? So it's a difficulty adjustment. So this is, sorry, this one. This is called the difficulty. This is going to make sure that you don't develop a block too quickly, or too lately. So it is going to adjust in such a way so that if your network power gets increased, this also increases over time. So this increases in such a way that the average time required to create a block remains at 10 minutes. Whatever may be the network hash power, the average time to create each block should remain around 10 minutes. And if the network, let's take, we can show you some examples also where it has dropped also. The network hash power has dropped recently when, I think last year, when China had banned all cryptocurrency mining, Bitcoin mining in the country. Lot of miners had to move, shut down their mining rigs and to transport it to some other countries like United States or Kazakhstan. They had to transport it. When that happened, the difficulty level decreased for a few weeks. Okay, and then again when they all started joining the network back again, it again went back up. So this happens. So the more people are there, it becomes the network, the amount of resource involved in solving the puzzle becomes higher. So then the possibility of solving the puzzle becomes easier. So to increase the difficulty of the puzzle, this is there. So why it is increasing or decreasing the puzzle difficulty is to maintain. It wants to maintain that 10 minutes of time. So if it becomes too easy, then more blocks gets created. If it gets too difficult, the blocks are not getting created, and people starts panicking. Why are then the network becomes very slow. If it's become too easy, then there will be a few people who will be earning a lot more than compared to others. So to have a balance in the system and to have a reliable mechanism, this is kept in place. I hope I've
Sir,
answered.
what decides the size of a block?
It is the protocol in the base layer. When you're building your blockchain, if you're building your blockchain, you decide what should be the block size. Right now for Bitcoin, it is around 1.5 MB. Where is the size of the block? So block size, this is close to little high, but usually a Bitcoin block will be around 1.5 MB. Okay.
And
so
sir, if the size increases, the reward also increases.
A reward will increase. The fee reward might increase because you'll be able to add more transactions. Yes. So if you are adding more transactions, this section of the fee reward will increase a bit. not this one.
So
So that is
how,
per block. Every block that is created, you get 6.25.
so that's a standard.
Yes, no, it is also varied over time. Right now, I think you all would have heard that there is only 21 million Bitcoin that can ever exist in the world, and already 18 million has been mined. Only few millions, 3 millions is left, right?
Yes,
And
sir.
to mine these three remaining 3 million, it is going to take 100 more years. It is going to, the last Bitcoin will be mined around 2140. 2140. Okay, so it is going to take close to 100 years from now to mine the last remaining 3 million Bitcoins. And this is the deflationary system that we have in place for the mechanism in place in Bitcoin. It was not 6.25 Bitcoin to start with. It was 50 Bitcoins to start with. If you were in 2009, that's like when you were in school, if you started mining, you would, for every block that you mined on your computer, you would earn 50 Bitcoins. Okay, every block that you mine, you'll earn 50 Bitcoins. Then slowly it became half to 25 Bitcoins after 4 years. Then after 4 more years, it became half to 12.5. And then recently in 2020, it again did a halving to 6.25 Bitcoins. And it is going to reduce again in 2024 to much further 3.125 Bitcoins. So that is how the supply, this is the newly created Bitcoins that are coming into picture. The 6.25 Bitcoin that you see here is freshly minted. This is the freshly minted Bitcoins. That is the first, this is the first time they are ever coming into the picture. Okay, they did not exist before the creation of this block. On creation of this block only, they have come into existence. So to complete this mining, this is how this has been built to have the, so it's called Bitcoin halving. You can check it out on Google. It's called Bitcoin halving. That is how the supply is going to reduce over time. So it's initially 50 Bitcoins. First, how also it's not like everything is pre-mined. So this is why they are calling this. They are called miners. Okay, they are mining the newly created Bitcoins. They're mining, plus validating the transactions. And 50 Bitcoins came. Then so this initially the total, when the first block was created, the total supply of Bitcoin was just 50. Then the second block was created, the supply of Bitcoin became 100. Then slowly it started increasing to thousands, right? So after a point, they had set a rule that it has to exist, stop at 21 million Bitcoin that can ever exist in this world. So they have created the Bitcoin in such a way that it's like a radioactive element, half-life. So this half-life of a radioactive element or a Bitcoin, we can say, is like 4 years. Every 4 years, the supply reduces by half. Every 4 years, the supply reduces by half. So until the 2140, the last remaining Bitcoin will be created.
Thank you, sir.
So, but if there's demand, then how do you quench that supply? Like, how does that work after that time, after that stipulated time? And also, who is it in consensus that everyone said that it will be 21 million Bitcoins at that end?
Okay, whoever created Bitcoin blockchain decided, and it's been hard-coded. It cannot be changed anymore. It is written in the base layer, in the protocol layer. It is written that 21 million is the total supply of Bitcoin that can ever exist.
Okay, sir.
Satoshi Nakamoto, whether it was an individual or a group of people, we don't know, but they decided that it will be 21 million. And there are many cryptocurrencies who have a cap. This is the maximum cryptocurrency this particular currency can exist. This is a maximum. This is the maximum it can exist. Currently, the supply is this much. So there is still some remaining that is yet to come into existence. But this Bitcoin can say that only 21 million can exist. But can any of the government of any of the country can say that this is the maximum supply of my currency is going to be? No, right? No country is going to say that this is the maximum supply of rupees or dollars or any other currencies, because that is inflationary. These are deflationary. This is like gold. The more you hold it over time, its value is going to increase. for you. But rupees, when you are a kid, you'd be able to eat with 10 rupees of 10 rupees you would be able to eat maybe 50 grams of dairy milk chocolate. But today there is still a version of dairy milk chocolate exists of 10 rupees, but the gram that you're going to eat is like maybe 35 or maybe 37, 36 grams you'll get, or maybe even lesser for 10 rupees, right? So what has happened over time? They cannot change the rate, increase the rate. So what they did, they have reduced the quantity they would give you. Right? That's the simple explanation to this is inflation, right? So the currency has inflated. Why it has inflated? Because the country, every single country does is they're going to print notes on top of the existing. Let's say every year there is supply is like 10,000 notes are there. Then next year they're going to print one more 11,000. So total supply becomes 11,000 notes. That is how the inflation happens. Slowly the inflation increases over year by year, but here it's deflationary. It's like gold. So any the more you hold it, the more value you get over time. So I'm going to add one simple concept here, that is currency, right? A currency. What is a currency? We know cryptocurrencies, we know fiat currencies, we know different kinds of currencies. The rupees, dollars, tokens are there, coins are there. All of them are currencies. Fungible tokens, everything are currencies. What are the characteristics of a currency? 3 characteristics. One is, it is a unit of account. Unit of account. You should be able to price, label products with it. Let's say, if I want to buy this book, I will say 100 rupees for this book. If I want to buy this laptop, maybe say 50,000 for this laptop. 50,000 rupees. I'm able to unit of account. I'm able to unit this account, use it as a unit of account for my calculations, for my purposes. Medium of exchange. You should be able to give this and get something back. So in previous, in the prehistoric era, stones were currencies. Tobacco was currencies. Cigarettes were currencies, right? Seeds, grams, these were all currencies that time. So because you're able to give it to someone and get something back in return. So barter system was there, but they were used as currencies. One is unit of account. Second is medium of exchange. You should be able to exchange with this. You'll be able to buy something or sell something with it. Third thing is the store of value. It should be able to store value with it. A very good example of store of value is gold. Gold, the more you hold it, the value will increase of the gold over time. Okay, but the rupee is not a very good example of store of value, because over time, if you had 10,000 rupees and kept it in your below your bed for 10 years, the value of that 10,000 rupees would have decreased in 10 years, right? So these 3 characteristics: unit of account, store of value, and medium of exchange. Any currency that you take, it has these three properties to it.
And when you have one question in the chat, I think it was asked before. Yeah.
Okay. Sorry. Yeah. Can Bitcoin be hacked by quantum computers? If so, then how is it safe for people who have invested in Bitcoin? That's a good question. So if Bitcoin, it's not just going to be Bitcoin. Every single system is under threat because of quantum computing. Could be. We are yet to see how well this will succeed, or things might go in the future. Right now, I would refrain from giving an answer to this question. So,
yeah, in a neutral term, so it is essentially that if quantum computers are very widely present, it means the infrastructure is also commonly present, right? So it will also be available to the miners also.
Exactly. Yeah. Thank you, Prakash. Yeah. Any other questions?
So yes, I think of course we'll have this as a continuous session. You can always ask some questions offline as well. We can cap it interactive, so as a follow up. We'll also give some materials later to the organizing team. And we'll have some follow-up questions as well before coming towards the next call tomorrow. Yeah. Anything else, organizing team? Yeah, I think we want to keep it time conscious, but yeah, we can have it offline as well. Any questions in the WhatsApp chat?
I'll be sharing my LinkedIn profile here. If you want to ask any questions or anything, if you want to just pick my mind, please feel free to reach out to me on LinkedIn. I'll be happy to answer your questions anytime.
Awesome, that's great. So BMS team, any closing thoughts? You're free to go forward.
Thank you, sir. And thanks to all the speakers for this amazing session today. It was very interactive, and I'm pretty sure everyone in the audience enjoyed it. And participants, know that the attendance form will be floated in the chat box. And tomorrow's the session reminder will start at 5 p.m.
Sure, and the agenda also will be shared. We will be sharing before end of day, so that, and if there is any follow-up questions, we'll also post it in the chat so that it can have some better idea while coming towards. So just as a context, yeah. So tomorrow's session is going to be a bit of fun. So in a sense, like we are going to go a bit philosophically, right? So we need some clarity on, like, if you're curious on market scenarios, like then how is regulation going to happen today or tomorrow? So for that needs some financial angle as well, right? So we are going to pick our minds from some of the leading investment firm folks who are going to come. We'll share the details in the chat. So you are going to have some very good answers, and from a very philosophical perspective as to why regulation exists and why it's also, maybe in one way they are necessary evils. At the same time, we will also try to see how innovation will still transpire over that. So that is one. And we'll also go a bit deeper on consensus mechanism. And we'll also have one hands-on session with a couple of volunteers or even with my other fellow speakers as well, in terms of how transaction happens on the newer latest cryptocurrency. So just to have an understanding why, how it exists, like Ethereum. So I think today you guys would have heard about the most fundamental cryptocurrency there is. So that is the prime version of prime example of public cryptocurrency, right? So public cryptocurrency, it's available for everyone to see. Whereas in private cryptocurrencies, private blockchains, you cannot see, right? It's only for between companies and so on. So understanding both also will help, is very helpful, because that's how a lot of functionalities are going to change. And you can also see in the news that it's taking steam in terms of adoption. But in terms of, it's always nice to learn a bit deeper than what you see in the traditional news, right? So only when you go through these fundamentals, you have a really good understanding, and it's going to take some time to actually go mainstream. So if you look back a bit of when the internet came, there were actually news reports saying that it's the latest fad, we are not going to adopt it. So that's how exactly we are exactly at that point right now, that this entire concept is a fad, we are not going to adopt it. So that's one takeaway you can have. So just concentrate on the fundamentals, and we will share some materials so that you guys can follow up before tomorrow's session as well. Yeah, thanks team. Yeah, thank you for your time as well.
Thank you all.
I'm sure it was very.
It has been a great session, and been wonderful talking to you all.
Yeah.
Really thank you for this opportunity, Prakash.
Yeah, sure. Yeah, thanks a lot, everyone. See you guys tomorrow. Yeah.
Participants do note that the attendance form and the link to the IEEE Discord server has been floated on the chat box.